everybody, this is Mr. Shaban, and today we're going to start the third unit of our syllabus. It talks about reactivity. It's a chemistry section as well. Reactivity is a unit which discusses the third chapter of chemistry for year 9. The lesson of today is going to discuss the metals and their reactions with oxygen. By the end of the lesson, you are expected to know that when a metal reacts with oxygen, a metal oxide is formed, and you need to know that metals have different level of reactivities. So basically not all the metals are the same. That's why we're going to do some comparisons right now between the metals based on the reactivity with oxygen. Keywords of today's lessons are metals and non-metals. As you can see over here, these are two metals, magnesium along with iron. These two metals have different behavior when it comes to the reaction with oxygen. As you can see over here, this magnesium was burned in the presence of oxygen. That's why it produces light, along with the heat energy is given off as well. So on the other hand, iron has reacted with oxygen, but it didn't produce any light or didn't produce any heat. You can compare between these two metals in an easy way. I want to ask you first a question before we start the comparison. Which one, from your point of view, represent a slow reaction and which one represent a fast reaction? I want you to look at the pictures. Which one is presenting or providing energy, giving out energy, a huge amount of energy in comparison with the other one? If a reaction gives out a huge amount of energy on spot, that means that the reaction is fast, and that means that the metal are way reactive than the others. So as you can see over here, magnesium has burned in the presence of oxygen to produce light and heat energy, and this is much more higher amount of energy given than the iron, because iron, it takes a long time in order to react with oxygen. This is a very slow process. So we can say that magnesium is higher in reactivity than the iron. We have discussed the magnesium, and we said magnesium burn in the presence of oxygen in a very fast reaction, and this reaction produce high amount of energy, and the chemical energy is stored inside the magnesium, if you remember from the lesson which we're discussing oxidation. So the chemical energy stored inside the magnesium was changed into light energy and heat energy, and this is producing a high amount of energy. When we compare it with iron, iron is a very slow reaction when it comes to the oxygen. When the iron react with oxygen, they react together in a very slow reaction. Not only that, but also the reactivity of iron is way lower than the reactivity of magnesium. Right now, I want you to know that metals are divided into different sections, as we're going to discuss right now. This is the periodic table. If you remember, we said the periodic table is a table where we rearrange the elements based on their properties. And we said we have 8 groups: 1, 2, 3, 4, 5, 6, 7, and 8. And we have 7 periods: 1, 2, 3, 4, 5, 6, 7, 8. Lanthanides and actinides, these elements, they should be belonging over here, but because they don't want to have an improper shape for the periodic table, so they have extracted all of these elements and they have placed them underneath the periodic table. So this place for the lanthanides, which should be over here, and this place is the actinides, these actinides. So if you can see that this periodic table has different colors. So I'm going to show you the color coding for these elements, because by understanding the color coding, you're going to know why we are talking about the reactivities. This is what we call alkali metals. Alkali metals are metals that are found in group 1. Then we have alkaline earth metals. These are found in group 2. And then we have over here transition metals. Transition metals, these are metals but are found in between group 2 and group 3. Over here we have semi-metals, elements that share some properties between the metals and some properties between the non-metals. The blue color, this represent basic metal. So majority of the periodic table, as you can see, are representing metals. The majority of the periodic table elements are metals. Over here we have like a ladder shape, that's a semi-metals, have some properties from metals, some properties from the non-metals. The green, these few elements are non-metals. Okay, and then we have over here, this is also a non-metal, but it's called the halogen because they are found in group 7. Okay, and then we have the natural gases which are found in group 8. Going back to the comparison between magnesium and iron. As you can see, magnesium is a metal that belongs to group 2, and iron is a metal that belongs to the transition metals, which is found over here. I'm going to show you the differences between the iron as a metal and magnesium as a metal. Magnesium is a softer metal. Physical property is softer. You can bend a piece of magnesium, as you're going to see in the lab. While the iron is very hard. You cannot bend an iron with your own hand. This magnesium is very, very, very reactive when you compare it with the iron. Iron takes a long time until it rusts. So the reactivity of the iron is very, very, very low when you compare it with a magnesium. So that's why when you put a piece of magnesium and a piece of iron in contact with oxygen, you're going to find this magnesium produces a huge amount of energy, and the iron is going to produce less amount of energy, because up to no amount of energy, because it's a very, very slow process. So that's a quick comparison between group 2, which is alkali earth metal, and transition metals. You need to know that transition metals are less reactive than group 2 metals. We're going to discuss that in details in year 10 in the IGCSE. So you're going to take lots of differences between alkali metal and transition metals. Okay, so let's discuss the chemical reaction between the metal along with oxygen. When metal react with oxygen, it produces metal oxide. If you remember, the name of the reaction is going to be called perfect oxidation reaction. Oxidation reaction is a reaction where a metal will react with oxygen to produce an oxide. Okay, right now I'm going to give you 3 minutes in order to figure out the answers of the course book questions, and then we're going to revise the answers together. Guys, time is over. Let's double check the answers together. The first question, name two metals that have atoms larger than those of sodium. So if you want really to figure out the answers, we need to go down. We'll find the periodic table and go down. Whatever the element which is found underneath the sodium is going to have a larger atom than the sodium. If you're going to move from left to right, you're going to find out also some atoms that are found larger than the sodium. So we're going to choose as an example calcium and magnesium. Which property of sodium is not typically of a metal? You know, we have a clue that metals are always very, very hard and they cannot be bent easily. So sodium has a different property. It's very soft and you can cut a sodium by the help of a knife. So that's one physical property that put the sodium apart from the other metals. Suggest why it might be difficult and dangerous to test sodium for electrical conductivity. Guys, sodium is a very, very, very reactive metal. So when it comes to electrical conductivity, sodium is so reactive and it may react with the air found in the atmosphere, oxygen, specifically oxygen, and burst into flames. It may be difficult to get good contact between the wires and the sodium because the sodium reacts with oxygen, and that's what makes the sodium stored in oil, because they need to block the air from the sodium. So they tend to put all the metals which are found in group 1 underneath an oil, so the oil will prevent the reaction between the metal along with the air, so no reaction will take place, and as a result you can store the metal for a long time. Good. Next question, write the word equation for the reaction of sodium and oxygen. When sodium is reacting with oxygen, it's going to make sodium oxide, and remember, this is what we call oxidation reaction. In oxidation reaction, a substance is going to react with oxygen in order to produce an oxide. In today's lesson, we have discussed the difference between the reactivity between group 2 and the transition metals. We said magnesium and iron as an examples, and you have seen how the magnesium have given out huge amount of energy when it reacted with oxygen, unlike the iron. Iron didn't provide that amount of oxygen, so iron is way less reactive than the magnesium. And we said some of the metals which are found in group 1, they need to be stored in oil as well, because we want to prevent the reaction between the metal and the oxygen, because they easily react together and burst into flame, and this is going to damage the metal. I hope you have enjoyed today's lesson, and see you next time.